Want to add external authorization to your FastMCP server without rewriting your tools? We'll integrate Permit.io's middleware to intercept all incoming requests, then configure it to check permissions against your existing policy decision point. You'll see exactly how to wrap your tools, like the greet and add functions, with authorization checks while keeping the core FastMCP transport and tool definitions unchanged.
From FastMCP, import FastMCP. From Permit FastMCP, middleware. Middleware import Permit MCP middleware. MCP equals FastMCP. Secure FastMCP server. At MCP, tool. Def greet name, SDR. Agree to user by name. Return hello, name. At MCP, tool. Def add a int b, int. Add two numbers. Return a plus b. Hash add Permit.io authorization, middleware. MCP, add middleware, Permit MCP middleware. Permit PDP URL equals http://localhost 7766. Permit API key equals your Permit API key. If name equals main. MCP, run transport equals HTTP.
This demonstrates external authorization integration through FastMCP's middleware system. The code shows how to add Permit.io's third-party middleware to enforce access control without modifying the core tool implementations, using FastMCP's extensible middleware architecture to validate requests against an external policy decision point. The pattern works by inserting Permit.io's middleware into FastMCP's request pipeline, where it automatically maps RPC calls to policy resources and actions. Unlike FastMCP's built-in auth providers like Auth0 or static tokens, this approach delegates authorization decisions to an external service while keeping the transport layer and tool definitions unchanged. The middleware intercepts each request, verifies permissions through Permit.io's PDP, and either allows or blocks execution based on configured policies. This approach provides an alternative to FastMCP's native authentication options when you need centralized policy management or complex authorization scenarios. By using middleware instead of built-in providers, you gain external policy control while maintaining FastMCP's standard tool exposure pattern through the @MCP tool decorator. The trade-off is additional infrastructure dependency versus the simplicity of FastMCP's integrated auth solutions. Let's break it down.
From FastMCP, import FastMCP. From Permit FastMCP, middleware. Middleware import Permit MCP middleware.
Imports FastMCP, the core framework for exposing Python functions as AI callable tools, and Permit MCP middleware, a third-party integration that adds Permit.io's external authorization layer. This middleware intercepts requests before execution, similar to FastMCP's built-in auth providers like Auth0 or introspection, but implemented through external policy evaluation.
MCP equals FastMCP. Secure FastMCP server.
This creates the core FastMCP server instance that will host and manage all AI callable tools. The string parameter sets the server's display name for logging and client identification. All tool registrations and middleware additions depend on this central instance.
At MCP, tool. Def greet name, SDR. Agree to user by name. Return hello, name.
The @MCP tool decorator registers this function as an AI-accessible tool in FastMCP's execution environment. It automatically generates an open API-compatible schema from the function signature and docstring, defining the tool's interface for AI agents. This pattern maintains clean separation between business logic and tool registration.
At MCP tool. Def add a int b, int. Add two numbers. Return a plus b.
The @MCP tool decorator registers this Python function as an AI-accessible tool within FastMCP's execution environment. It automatically generates an open API-compatible schema from the type hints and docstring, enabling AI models to discover the tool's capabilities, validate input parameters, and invoke it with proper argument types. This implements FastMCP's tool pattern, where regular Python functions become remotely callable operations, with the framework handling all serialization, transport, and execution coordination. The decorator transforms what would be a local function into a network-exposed capability while maintaining the original Python interface.
MCP, add middleware, permit MCP middleware. Permit PDP URL equals http://localhost 7766.
This adds Permit.io's external authorization middleware to FastMCP, enabling pre-execution permission checks against Permit's PDP service at the specified endpoint. Unlike FastMCP's built-in auth providers like Auth0 or static tokens, this third-party integration handles authorization through external policy evaluation while keeping your tool implementations clean. The middleware pattern shown here mirrors FastMCP's native auth system, but delegates decisions to Permit.io's service.
If name equals main. MCP, run transport equals HTTP.
This is the Python entry point guard that prevents server execution during imports. The MCP, run transport equals HTTP, call starts the FastMCP server using HTTP transport, one of several supported protocols in FastMCP's architecture. The middleware added earlier, Permit MCP middleware, is a third-party integration from Permit.io that implements external authorization, similar to FastMCP's built-in auth providers, but through external policy evaluation. This pattern separates access control logic from tool implementation while maintaining FastMCP's standard request flow. Authorization middleware pattern. The Permit MCP middleware integrates external authorization into FastMCP by intercepting tool calls before execution, delegating access decisions to Permit.io's policy decision point. This third-party middleware complements FastMCP's built-in auth providers, Auth0, introspection, static tokens, when you need centralized policy management across services. The transport equals HTTP parameter selects one of FastMCP's supported communication protocols, with others available for different deployment scenarios.
The server that delegates its authority becomes more powerful than the server that hoards control.